Welcome in heat transfer lecture series. Today we will see the subject heat transfer, in which we are going to study the topic different modes of heat transfer. So this is the basic and fundamental parts of unit number first, that is introduction and basic concept in heat transfer. So in modes of heat transfer, first we will see the introduction. So before studying the heat transfer subject, we already know the basic fundamental required for the heat transfer is thermodynamics. So thermodynamics is a science that deals with the transformation of one form of energy into another form of energy. So in thermodynamics, we studied that heat and work are energy in transit having unit watt or joule per second. So in thermodynamics, interaction between heat and work were studied, but the rate of heat transfer and time and estimation quantity of heat were not studied. So the main objective of heat transfer course are to study the temperature distribution and to estimate the rate of heat transfer in the thermal equipment. So you can define heat transfer is the energy transit due to temperature difference. So here you can see this temperature difference is the driving force for the heat transfer. So temperature difference, when there is a temperature difference or delta T, there is a heat transfer. So it is similar to pressure difference for flow of water and potential difference for flow of current. If you see the different applications in heat transfer, then boiler, furnaces, heat exchanger, solar energy, refrigeration and air conditioning system, thermal equipments are the applications of heat transfer. So heat transfer generally occurs by three modes of heat transfer, that is conduction, convection and radiation. So first mode of heat transfer we will see, that is conduction. So heat transfer in material takes place due to molecular interaction. Heat is conducted from molecules to molecules by combination of two mechanisms. That is, first one is drift of free electrons and second one is lattice vibration. So in drift of free electron, the different metals have different numbers of free electrons. Free electron move atom to atom and conduct heat. So good conductor of electricity is also a good conductor of heat. So in lattice vibration, due to restricted motion of molecule, heat is conducted within the material, which may be solid, liquid and gas. In metal, heat conduction is mainly due to drift of free electrons, and in non-metal it is due to lattice vibration. So if you see in conduction mode of heat transfer, if you find out the heat transfer rate, then the basic fundamental law is used for calculating the heat transfer rate in conduction, that is Fourier law of heat conduction. So Fourier law of heat conduction, if you consider a case of heat transfer through a wall by the process of conduction, then the rate of heat conduction is given by, that is del Q is equal to minus K dt by dx. So here in this figure you can see this is a wall having thermal conductivity K with thickness L. One side surface temperature of wall is T1, other side surface temperature is T2. Then you can find out the rate of heat transfer, del Q is equal to minus K dt by dx, where del Q is the rate of heat transfer, K is thermal conductivity of the wall, A is surface area perpendicular to the direction of heat flow, and dt by dx is your temperature gradient. So this negative sign indicates that heat is always flow from higher temperature zone to lower temperature zone. So that is from hot to cold area. So with the help of this you can find out the heat transfer rate in conduction mode of heat transfer. So in second mode of heat transfer, that is convection. So convection heat transfer due to bulk motion of fluid because of buoyancy effect produced by difference in temperature or external heat. So when there is a temperature difference between the surface and the fluid which is in contact with it, then the convection heat transfer takes place. So there are two basic types of convection, that is natural convection and forced convection. So in natural convection, convective current are set up due to buoyancy effect. The fluid is moving and transfer heat due to density difference caused by temperature difference. So because of the density difference that caused by temperature difference, so the movement of fluid takes place because of this density difference. So while in case of forced convection, the fluid is moving by some external aids such as fan, pump or blower, the movement of fluid takes place with the help of some external source in a forced convection. So in convection, you can find out the rate of heat transfer by using Newton's law of cooling. Just like the Fourier law of heat conduction in conduction mode of heat transfer, the rate of heat transfer in convection you can find out by Newton's law of cooling. So the rate of heat transfer by convection is determined from Newton's law of cooling, and it is expressed as, that is, Q convection is equal to HA delta T. Delta T is surface temperature minus fluid temperature, where this H is the convection heat transfer coefficient, A is the surface area through which the heat transfer takes place, Ts is the surface temperature, and Tf is the bulk fluid temperature away from the surface. So the convection heat transfer coefficient H is not a property of fluid. It is an experimentally determined parameter whose value depends on number of variables such as surface geometry, the nature of fluid motion, and the property of fluid and the bulk fluid velocity. So by using this you can find out the rate of heat transfer in convection mode of heat transfer. The third one is the radiation. Any body having temperature more than zero absolute temperature radiates energy, and it mainly depends upon the absolute temperature and surface area. So the energy radiated is travel in the form of electromagnetic waves according to Maxwell theory, and in the form of tiny particles, photons, according to Planck's hypothesis. So both theories are equally accepted. So if you find out the rate of heat transfer in radiation mode of heat transfer, then you can use the Stephan-Boltzmann law. So this is the basic fundamental law of radiation. So rate of radiant energy emission is proportional to the fourth power of its absolute temperature. So Stephan's law and is expressed as P is equal to emissivity into sigma into area into T raised to 4, where sigma is the Stephan-Boltzmann constant. The value of this constant is 5.67 into 10 raised to minus 8 watt per meter square Kelvin raised to 4, where emissivity, which is the number in between 0 to 1, and T is the temperature in Kelvin. So emissivity always varies from 0 to 1. So by using this law you can find out the heat transfer rate or the radiant energy emission in radiation mode of heat transfer. So here you can see this three modes of heat transfer that we already studied, that is conduction, convection and radiation. So conduction through a solid or a stationary fluid. So this is the wall we are considering. So T1 is the temperature on one surface, T2 is the temperature on second surface. Here T1 is greater than T2, and this is the heat transfer rate. So in conduction mode of heat transfer. Similarly, you can see the second mode of heat transfer, that is convection mode of heat transfer. So this surface temperature Ts and moving fluid temperature T infinity. When this fluid is moving on this surface, then there will be a delta P in convection mode of heat transfer, that is Ts minus T infinity. Here Ts is greater than T infinity. So this is the heat transfer rate by convection. Then net radiation heat exchange between two surfaces, that is here you can see that surface 1 having temperature T1, surface 2 having temperature T2. So this is the radiation mode of heat transfer. So these are the three modes of heat transfer. So in conduction mode of heat transfer, we can find out heat transfer rate by using Fourier law of heat conduction. In convection mode of heat transfer, you can find out heat transfer rate by Newton's law of cooling, while in radiation mode of heat transfer, we can find out the rate of heat transfer by using Stephan-Boltzmann law. So here you can see this is the example in which all three modes of heat transfers are covered. Here this is the sun heat. This is the solar panel. So on this solar panel you can see that sunlights are coming on this panel. So here this is the conductive heat loss occur by heat flow from one material to another. So here that is conduction mode of heat transfer. Then this convective heat caused by wind across module. So from this solar surface to the atmosphere, there is a convection mode of heat transfer. While this module radiates heat to the environment. So if module radiates heat to the environment, that is the radiation mode of heat transfer. So this is the example in which all three modes we find combined, that is conduction, convection and the radiation mode of heat transfer. So conduction mode of heat transfer, we can find out Q with the help of Fourier law of heat conduction. In convection mode of heat transfer, we can find out heat transfer rate Q with the help of Newton's law of cooling. And in radiation mode of heat transfer, we can find out rate of emission or heat transfer rate with the help of Stephan-Boltzmann law. So these are the three basic fundamentals law for these three modes of heat transfer. Thank you for this different modes of heat transfer lecture. Thank you.